It's indeed an honor to be a part of this panel, speaking to Bermuda tonight. I'm here in the capacity of having done a doctorate in immunology at the University of Oxford prior to completing surgical residency or surgical training at Harvard. While doing my PhD, I spent my time at Oxford looking at vaccine strategies, looking first at boosting the immune response to H1N1 models and then to melanoma, in the very same place that the work for the AstraZeneca vaccine eventually came out of. Importantly, while doing my thesis there, I met my wife, a Bermudian, and 2.5 years ago, she and I, with our 1-year-old son, moved back to Bermuda, a place where I now call home. So over the last year, I've heard so many fears and concerns about the virus, and not only the virus, but the vaccines, and I totally understand where they're coming from. For instance, why get vaccinated if it doesn't completely prevent future infection? Okay, I get infected. No, they're saying that's different from disease. Is there really a meaningful difference between infection and disease? Or what about natural immunity? If I catch COVID, recover from COVID, won't I have immunity against future infections? Why do I need to go there and get the vaccine? And then what about this RNA technology? It seems so new. Have they done enough research, or do we really know how much was done to know that if we have any side effects or not? These and other questions, if you can just stick with us for my first 10 to 15-minute presentation, I hope to touch on these and more, and then the rest of the panel the same. So let's get started. So I'm sharing my screen here, and I really believe to understand the COVID-19 vaccine, it is critical to understand how the immune system actually protects us, about adaptive immunity. So I'll discuss that first, then I'll talk about what exactly the COVID-19 vaccine is. And then I'll talk about what happens to the virus if you get infected and are not vaccinated, then what happens to you if you're infected and not vaccinated. Then we'll talk about the risks and complications of the vaccine, and then I'll save the questions for after the entire panel has presented. So I want you to realize that the immune system is an army. It's literally a police force with different members that have different functions, and like every army, there's a general. Here it is. It's called the CD4 T helper cell. Tells people what to do. You have a detective intelligence officer called an antigen presenting cell. It goes out and finds intruders and finds information for the immune system to respond to. You've got the sniper, the shoot to kill guy, the infantry officer. We call them the CD8 killer T cells. And then you have the regular policeman who carries handcuffs. And when I say handcuffs, that's what antibodies are. If you hear antibodies, what are they? They're literally just handcuffs for a particular intruder. So what happens is that all these cells are made in the bone, the marrow of the bone, and then they leave the bone marrow and go to an organ called the thymus, which is in the upper chest. And that's what school is for them. In the thymus, they learn what makes you, you. What are your building blocks for your cells? We call those building blocks antigens. And for the rest of your life, after that, this detective you see on the screen is looking for two things. Anything that's not you, i.e. a virus or a bacteria, or anything that's an altered version of you, a mutation of you, i.e. a cancer cell. What happens when he finds this intruder? He picks him up and carries him to the police station, i.e. lymph nodes. Lymph nodes, that's all they are. The ones in the head and neck, that's the precinct for any infection up here. The ones under the armpit, anything going on in the breast and upper back, that's what they are. They're just police stations. And in the police station, this detective presents this intruder to the general and said, "General, look what I found. I found this guy. He's not one of us." The general calls in the police, i.e. the B cell, and say, "Cuff him." Calls in the sniper and says, "Sniper, shoot him. But before you cuff him and shoot him, I need a favor from each of you. The B cell, the policeman, I need you to make a whole squadron, multiply a squadron of yourself that will have handcuffs specifically for this intruder. So that if he ever shows up again, you cuff him on arrival. You don't need the detective to find him first. You're there, you cuff him. Sniper, I want you to do the same thing. Have a SWAT team. These are the good guys on the right side of the scene, the snipers and the police, the memory T cells, we call them, the SWAT team. If you see this guy again, shoot him on arrival." Here's the problem, Bermuda. The time it takes to create this specialized force for this intruder takes 2 weeks. So if you run into a dangerous virus, it can do a lot of harm in 2 weeks before you have that specialized SEAL Team 6 security force to attack it. So what's a vaccine? Many, many years ago, scientists say, can we give the immune system a heads up about these dangerous intruders so that they can form these forces, so that if they ever run into the real thing, they've got the security force before this thing can cause damage? No. If you listen carefully, measles, mumps, polio, 50, 60 years ago, what they did is they found this gunman, that virus on the bottom hand of the screen, took away his gun and gave you the live virus without the gun. So that's why people are like, oh my gosh, they got the vaccine. Yes, those vaccines were the live virus without the gun. That's not what the COVID vaccine is. So I see where that came from. What about the flu shot? What did they do? They took the gunman, took away his gun, killed him, and then gave you the dead gunman. They call it inactivated or killed virus. That's what the flu shot is each year. Killed, but that's not what the COVID vaccine is. They looked at this virus and they said, what makes it unique? They said, this guy has a green hat. And this hat is critical for him getting around. He's the only one with something like that. Specifically for the virus, it's that little red spike coming off the shell. We call it the spike protein. It's not the virus, just the protein. So if we give them the hat, i.e. the spike protein, will this detective now present it to the general, and general said to the police, hey, if you ever see anybody show up with this hat, cuff him. If you ever see anybody show up with this hat, shoot him. Not the virus, just the hat. We gave you just the hat. The hat can't hurt you because they're not giving you the live virus like they did back in the day. Because vaccinology has tried to get safer with time. But here's the fascinating thing. They found that if they gave you the hat alone, this SWAT team of killer T cells, they specialize at going after things that get inside cells. They didn't form a good SWAT team. It's like, oh gosh, so, do I have to give him the whole virus? No, they said, well, if we got the hat inside a cell, then it formed a really big army. So the question is, how do you get it inside a cell, i.e. inside a house? I want you to think of the entire body as a neighborhood, and every cell is a house. You have 37 trillion houses in this neighborhood. And you need to know what's in the house to understand how to get the hat in the house, i.e. the spike protein, not the virus, just the protein in the house. Every house has these little workmen, that little elf there, that repairs the house, helps build your cell, repair if a cabinet needs changing or if the bed needs repairing, this guy repairs it. He makes the proteins. And how does he know? Because he has a manual. He has an instruction booklet on how to repair your house and what makes you you. That booklet is called RNA, messenger RNA. That's what it is. It's literally just a booklet of what makes you up in your cell. There's another booklet called DNA. These ribosomes read the RNA booklet. So they said, I wonder if we can give him a booklet on just the protein, just that little hat. He makes the hat, now the hat's in the cell, and the immune system goes wild and says, there's something foreign in there. Let's create this army. So if it ever shows up, we'll kill it. That took 30 years to figure out. 30 years. It didn't happen overnight. They've been working on this, how to get the hat in the cell with this booklet for 30 years. And how did we learn how to do it? From viruses. If you look on the screen, that's exactly what viruses do. Here we have COVID binding to your cell, the SARS virus, and what it does, it deposits its own booklet in you, hijacks your workmen. They use the booklet of the virus to make the virus. It ravages your cell using all the raw material, multiplies and moves to the next house and keeps going, destroying houses one by one. So we said, can we create a shell, deposit the booklet that tells you how to make the hat? The hat's in there now, and then you create an immune response. So now you know what RNA is. It's just a booklet. Now you know all they've done is given you the hat, not the virus. What's the difference between the vaccines? So Pfizer and Moderna, that shell that delivers the book, that tells you how to make the protein, delivers the RNA, they made the shell in the lab. And what did they make it out of? Fat. Lipid is the medical term for fat. Nano means small. It's not a chip. It just means small particle, a small particle of fat. In cases this book drops it inside you, because without it, it just broke down the book. The book never got there. And they had to use decades of research to figure that out. Oxford and Johnson & Johnson, they took a little harmless virus, gutted its insides, and just took its shell, it's called the adenovirus, and used that as the vector, as the shell to transmit its book. The first three, you need 2 shots in order to say, oh, the immune system say, yep, this hat's a problem. We need to create an army about anything that shows up with this hat. Johnson & Johnson did it in 1 shot. No, everybody's talking about which one's better than the other. They had different measures of how to figure out which one is efficacious. All of them are good. All of them prevent 100% of the time disease, ICU admission, and death. Now you're like, hold on. But you can still get infected. Hold that thought. Let's talk about the difference. If you get infected and you're not vaccinated, what happens? What happens to the virus? The virus, as I tell you, just wants to bind to your cell, hijack your workman, and multiply. But what's unique to viruses? Every time they multiply, they change a little. So look at this gunman. He's got a blue jacket, he's got a green hat, he's got a gun over his back. Sometimes he just changes his coat. If he's got a yellow coat, red coat, may not be a big difference. Sometimes they pick up a bigger gun. So what does that mean? You got a more deadly virus. What happens if they change their hat? No, that's a problem, because the vaccines are now all against this green hat. So if somebody gets infected and the virus changes in that person, you've now created a new monster that the vaccinated people are not protected against. And we're back to square one. So current vaccines wouldn't work against if they change the hat. So far, the hat hasn't changed enough. Out of the millions of variants that are out there, remember, he needs the hat to get around. So it's changing a little bit, but it hasn't changed enough that we still aren't protected. If you are vaccinated, you got your sniper at the door, you've got the police at the door waiting on some guy to show up with the green hat. They cuff him and they shoot him. So what ends up happening? You got infected, i.e. he broke in the front door, your security force is there, but he can't do anything because they cuffed him. So yeah, I tested positive, but he can't multiply. And if he can't multiply, then there's a very, very low chance of you spreading it. And guess what? Even more importantly, he can't change. He can't change his hat. Therefore, you can't create a different monster. So it's not just protecting you from getting sick. It's protecting you from being the host that creates the new monster. This isn't the first time we've seen this monster. SARS in 2003 was corona. MERS, Middle Eastern Respiratory Syndrome sickness, was corona in 2012. 2019, it came back. It's like Terminator 2. That's why they call it SARS-CoV-2. It just changed. You don't want to be the one being the host that causes this virus to change and then damage everyone else as well, not just yourself. If you get infected and not vaccinated, what about my own immunity? Why do I need the vaccine? If I get it and I recover, won't I be immune? Won't I have the security force against this thing that just infected me? And then therefore, why don't they count me in part of this herd immunity? The thing is, each person, what we've learned when they get infected and attacked by this monster, I might create antibodies against the blue jacket. You might create antibodies, handcuffs against anything with a gun. Tom might create antibodies against the hat. We all create antibodies to different parts of the virus. That's why they say some antibodies are protective and some aren't. Some create a lot of antibodies and some don't. What we know is that if we give you just the hat, the antibodies you create will protect you against any form of the virus that's out there right now, and that it'll be protective. So that's why if I just caught it, I may have antibodies against the blue jacket. And then this thing changed, has a yellow jacket. I'm not even protected 3 months from now because I'm looking for something with a blue jacket. So they can't count me as part of the ones who are immune. So how do we get herd immunity if this thing keeps changing? Thankfully, it hasn't changed its hat yet. So if we vaccinate as many people as possible while it still has a green hat, now there's so few people left in which this thing could actually change, it eventually dies out because our security forces cuff him and kill him before he can multiply or change. Now, has this thing been changing the hat? Yes. That's why even though there are millions of variants, the ones that people talk about, the UK variant, the South African variant, the Brazilian variant, why are they notable? Because the hat, the spike protein is what is changing a bit. Thankfully, it's still green, but it might be a baseball cap instead of a top hat. And your immune system still recognizes it. If you look on these numbers, 84 to 74%, there's a slight decrease in how much it recognizes it, but still recognizes it really strongly that it will attack it. It's a race against time. Can we vaccinate enough people before this thing changes? And if it changes past what we need, that's why we may need a booster, because we need something else. If it's changed past the green hat, so far we're not there yet. So far we're not there yet. We're still protected because all the variants have this green hat. If you're infected and not vaccinated, what happens to you? Remember I said these viruses like to break into houses? Each of them have a house that they like. This virus likes to break into your lung cell, the pneumocyte, the cell that exchanges oxygen and carbon dioxide. That's why your oxygen levels fall when it destroys those houses by multiplying itself. But that's not the only thing it does. It's not whether, oh, I survived or I died. If you survived, a lot of evidence is coming out now. You can check the CDC website where it's affected your heart, your lungs, your kidneys, your skin, your brain. The long-term effects they're talking about the long haulers where people are handicapped. They're damaged on all the organs because they caught this thing. All that data is still coming out. What we know about side effects of the vaccine, everybody might get a little soreness for a day from the shot, but when you go for your next shot 3 weeks later, your immune system has the army because it's been more than 2 weeks. That army works better when your temperature is a little higher. That's why you have a little fever when you get the hat again, not because you got the virus, because you got the hat. He says, hold on, is he here? No, you got chills and fevers and you have aches and pains as the immune system is scouring the body to find an intruder. It doesn't find any virus. So after 12 hours, symptoms are gone. Those symptoms were from your immune system responding, not the virus.